Hi friends, today I am going to talk about a very important topic related to AWS EKS known as IRSA, which stands for IAM Roles for Service Accounts. So what exactly is IRSA? IRSA is a way in which you can associate an IAM role with a Kubernetes service account. This service account can then provide AWS permissions to the containers in any pod that uses that service account. In simple terms, IRSA is the AWS EKS native way to allow applications running on EKS pods to access AWS API using permissions configured in IAM roles without having to create or distribute your AWS credentials to the containers. For example, if your application or pod needs access to AWS S3 buckets, it can do so using IRSA without needing to configure any explicit AWS credentials. And we'll see how in a few minutes. So, what are the benefits of using IRSA? Number one, principle of least privilege. By using IAM roles for service accounts, you no longer need to provide extended permissions to the node IAM role so that the pods on the node can call AWS APIs. You can scope the IAM permissions to a service account, and only the pods that use that service account have access to those permissions. The second benefit is the credential isolation. A container can only retrieve credentials for the IAM role that is associated with the service account to which it belongs. A container never has access to the credentials that are intended for another container that belongs to another pod. The third benefit is auditability. Access and event logging is available through CloudTrail to help ensure retrospective auditing. Now let's try to understand the flow depicting the pod trying to access AWS services. But before we dive into the flow, there are a couple of things that you need to understand. Whenever you create an AWS EKS cluster, it is by default becomes an OpenID Connect provider or IDP, meaning it can be used to perform federated access just like the Google, Microsoft, Facebook identity providers. Now, AWS IAM supports IDPs that are compatible with OpenID Connect or OIDC to establish trust relationships to access your AWS account, which means that we can use the AWS EKS OpenID Connect provider to access the AWS services using the IAM Identity Federation. Now, here is the flow. Every pod is associated with a service account which gets issued a projected service account token which happen to be a valid OIDC, JWT or JWT tokens for pods. The pod sends this service account JWT token to the AWS IAM. The AWS IAM supports federated identities using OIDC and is able to validate and accept the JWT token and then sends the JWT token to AWS STS that calls the assume role with Web Identity API and generates a temporary IAM role credentials and sends it to the pod. The pod can use these credentials to access the AWS services as per the IAM role policy. Okay, now let's start with some hands-on demo. Let me start off with creating an EKS cluster itself. So I have a YAML file EKS cluster irsa.yaml with the cluster config like so. The name is EKS cluster IRSA, the region is US East 1, the Kubernetes version is 1.22, and I've kept it simple with one node for now. Let me create the EKS cluster with this configuration. So this will start creating the EKS cluster and this will take some time. So I'll pause the video here. Okay, after a few minutes, the EKS cluster is ready in the region US East 1. Now, if we go to the AWS Management Console and search for EKS service, and we see that the cluster is created here. If we click on the cluster name, and scroll down, we see that by default it becomes a OpenID connector provider with the URL as this. Now I can go to the console and run this curl command. The URL is basically the OpenID URL that we saw on the AWS management console. So I'm appending the URL with dot well-known OpenID configuration, and I'm piping it to JQ to pretty print the JSON output from the response. And we see that it gives a JSON response with the issuer, JWKS, URI, authorization endpoint, so on and so forth. Now let's see how to add this identity provider with the AWS IAM service. Now here's the documentation page from the AWS website. So the ekscuttle command can be used to add this identity provider to the AWS IAM service. Or other ways to go to the management console, go to the IAM service and add the identity provider manually. There's a add provider button here. You can follow the steps and add the provider manually, but I'll go with the eksctl command to add the identity provider here. If I go to the console, I'll run the ekscuttle utils associate IAM OIDC provider dash dash cluster and then the cluster name and dash dash approve. So this will go ahead and add the IDP to the AWS IAM service. So it says it has created the IAM OpenID Connect provider. Let's verify it from the console. So if I go to IAM and now refresh this page, you see our identity provider has been added here now. Now the goal of this demo is to show how a pod or an application can access AWS S3 buckets. So let me show you the setup that I have in S3. So if I go to the S3 service, here you see I have a bucket named my IRSA test in the US East 1 region. If I click this bucket, I have a test file uploaded in this S3 bucket. So we'll be using this setup and see how we can access this from the pod or the application running within the EKS cluster. As a next step, let's create IAM policy which will allow access to the bucket that we just created. So on another tab, I'm opening IAM in the AWS Access Management console. I'll go to policies. Let's create a policy by clicking this button here. We go to the JSON tab and then we'll enter a policy like this, which says basically allow the actions S3 list bucket, get object and get object version. And the resource is the ARN of the bucket that we just created. So if we go to the S3 in the properties tab, you'll see the ARN of the bucket that we just created. So I've copied that and pasted here in the policy. So let's click on next tags. Let's keep it default. Let S3 access policy and then say create policy. So here's the policy that we just created. If you open this, we'll be able to see a ARN for the policy that we just created, right? Next, let's create a IAM role and the service account for the Kubernetes pods. So basically, I'm following the documentation link that you're seeing, and I've included this link in the description of the video. So we have been following step-by-step guides, whatever is listed here. So first we created the OIDC provider. Now, as a next step, let's create an IAM role for the service account. Now, I'm going to follow the eksctl command way here that's listed here, but the same thing can be done via the AWS CLI as well as from the management console. Now, I've created this eksctl command as per that documentation, and I have provided the name of the service account, which is IRSA service account. The namespace would be default. The cluster name is the cluster that we just created. The role name is S3 access role, and the policy ARN is the ARN that for the policy that we just created, which is this one here. So let me copy this command and run on the console. So this will go ahead and create the IAM role as well as the service account. Now this might take some time, so I'll pause the video here. Okay, so the IAM role and service account creation has completed. So let's go to the management console and verify. So if we go to roles, we'll see the role that we just created, right? So the name is S3 access role, which we gave. And in the permissions, you'll see a policy attached, and this is the same policy that we had created earlier. Now, the important thing is in the trust relationship tab, if you go there, this is a very important piece of configuration. So if you see here, the effect is allow, and the principal federated ARN is the OIDC provider of the EKS cluster that we had created. And the action says STS assume role with web identity. And in the conditions section, you see there are two conditions. The subject here is the service account, the Kubernetes service account in the default namespace, and the name of the service account which we created, which is IRSA-service-account. Now, this is the most important line, right? If your IRSA thing is not working, then this most probably the place where you have made some mistake. So please pay careful attention here and make sure you get the names of the service account and the namespace correct. Now there's the audience also is listed here, which is sts.amazonaws.com. Now let's go to the Kubernetes cluster and verify if the service account is created. So if I do kubectl get service account in the default namespace, so it returned two values. The one is the default service account and the second one is the IRSA service account that we just created. Let's take a look at the output in a YAML format. So we'll do kubectl get SA, then name of the service account, and let's output it as a YAML. So one thing to note here is in the metadata annotations, you see there's an annotation added by default by the EKSCTL command. So there's EKS Amazon AWS.com role ARN, and this is the role of this is the ARN of the IAM role that we just created. So this line is very important. If you don't have this annotation in the service account, the IRSA won't work. Now, if you go to the documentation after this creation, there's another step which says associate an IAM role. So it talks about adding the annotation of the role ARN. Now, since we used EKSCTL command in the previous step, this thing has been automatically taken care by the EKSCTL command. But if you are doing manually using AWS CLI or the AWS Management Console, make sure when you create the service account, you add this annotation with the ARN of the role name. Now that we have everything set up, let's move on to the application and see if it can access the S3 bucket that we created. So I have a YAML file to create the pod. The name is myapp.yaml. So if you see here, the kind is pod. The metadata name is AWS CLI. So I'm choosing AWS CLI image here just to demo. But the fact is that you can use any image as your application, right? That is running in the Kubernetes cluster. So just to demonstrate, I have not used any service account here. So this pod would be created in the default service account in the default namespace. So I just want to show that this pod will not be able to access the S3 bucket that we created, right? Because it's not attached to the service account that we created. So let's go ahead and create this pod and see. So I'll say kubectl apply dash F. Sorry, the namespace was listed as test by mistake. So let me remove that. So this will now create in the default namespace. So if I create, so if I do kubectl apply myapp.yaml again, this has created the pod. So let's see the status kubectl get PO. So it says container creating. Let's watch it until it's running. Okay, it says it's running now. So if we exec into the pod now by doing kubectl exec dash it AWS CLI, and we say the command as bash. So now we are inside the AWS CLI, but this can be any pod, your own application running on the EKS cluster, right? So now if I do AWS STS get caller identity, this will show the identity of what is running, right? So currently, if you see the ARN, it says assumed role EKS CTL cluster IRSA node group node instance role. So basically this pod has assumed the node IAM role. So this definitely won't have access to our S3 bucket, but let's just verify. So if I do AWS S3 ls, it should give it an error saying access denied, and as expected, we see the error here. Now let's destroy this pod and create the pod again in the service account that we created, which is associated with the IAM role, which allows us access to the S3 bucket. So now let me exit from here and do kubectl delete dash f my app. So the pod is deleted now. So let me quickly edit the my app.yaml, and under spec, let me specify the service account name as the IRSA service account that we created using the EKSCTL command. So now once we apply this, the pod that will come up, that should assume the IAM role, which has the access to the S3 bucket. Let's quickly verify that. So let me save this and do kubectl apply dash f my app.yaml. It says created. Now if I do get pod and watch it until the pod is in running state, okay, it's running now. So let me exec into it again, kubectl exec dash it aws dash cli, and the command is bash. Let me again run the sts get caller identity just to verify what it shows this time. Now, in the previous step where it was not associated with a service account, it assumed the role of the node itself on which this pod was running, right? But now, since the service account has been changed, if you see the ARN, it has assumed the IAM role which we created, S3 access role. It's an assumed role. So this pod has basically assumed the IAM role which has access to the S3 bucket. So if we do AWS S3 ls, now when we do AWS S3 ls, unfortunately it's again giving access denied. Let's try doing AWS S3 ls specifically on the bucket that we created. Oops, I missed the word S3. So let me add S3 here. And there you go. It works for this bucket. Now, why is that? When we did AWS S3 ls, it gave access denied. But when we did AWS S3 ls on the bucket that we created, it gave out the file that we had uploaded. For answering that question, let's go back and take a look at the policy that we had created. So if we go to the roles and the permissions, now, if we take a close look at the policy, the effect is allow. It says you can list bucket, get object version, but the resource is the S3 bucket that we created. So this policy only allows access to this bucket and nothing else. So when we did a blanket AWS S3 ls command, what it was trying to do is list all the buckets within the account for which the policy does not have permissions. But the policy does allow you to list the S3 bucket for the bucket that we created, my IRSA test. So this demo successfully demonstrates how the IAM role for service account can be used. When this pod was associated with the service account that was tied to the IAM role, it was able to access the S3 bucket. Another way to verify that the pod has assumed the role that you want is checking the env, basically the environment variable. So if you see there's an environment variable called AWS underscore role underscore ARN, which has the ARN of the role that we had defined, and also the AWS underscore web underscore identity token file, which points to the service account token. So these two environment variables, if that's present, it also confirms that your pod has basically assumed the S3 access role that we had defined in the IAM role. Another important thing before we wrap up, I wanted to show you guys is this, right? So if when I run kubectl get secrets, you see there's a IRSA service account related token that we had spoken during the flow, which we saw right from the pod to IAM, then STS, which returns a temporary credentials for the AWS, right? So this is exactly the token. Now, if we run kubectl describe secret, so this basically shows the token, right? So this is the token which we were talking about, the JWT token. Now, if we copy this token value, right, and go to a website called https jwt.io, if we scroll down here, so there's a place where we can paste this token, right, and analyze what this contains. So when I paste this here on the right hand side, you see the payload data. Now this is what the token contains, right? The ISS shows as Kubernetes service account. The service account namespace is the default because we were using the default namespace. The secret name was IRSA service account token. The service account dot name is IRSA service account. And the important thing is the subject here, right? System service account default and then the service account name. This is the same subject that we used in the IAM role trust relationship. If we go to this tab and this subject, right, this is exactly the same which is found in the JWT token that we are seeing it now. So that's all I had for the demo with this IRSA. Hope you enjoyed the video. Thanks for watching.